Okay, now for the data we have among the world's richest people, we have the amounts recorded in the number of billions of dollars they have, and in looking at the determination of the mean value, if you take all 10 numbers by the billions, you have at the peak you have 59 billion, at the minimum you have 17 billion, and adding all the numbers you have 272 billion divided by 10, so we have for the mean value we have at 27.2 billion. Okay, now in terms of the median, okay, we have 10 billionaires, so you have 17, 17, 17, 18, 19, 19, 26, 28, 52, 59, again for the median. Do not forget to arrange the data in order from smallest to largest. Okay, so we have an even number of data pieces, and so the median is going to be taking the mean of the fifth and sixth items, and so we have in between 19 and 19, the median is going to be at 19 itself. And now this is a first type problem where we have the median to be identical to the number before and the number after it. And now I'm just going to throw in another analysis among the data, and that is if you were to sift through the numbers and break it down in terms of quartiles. And if you were to determine the first quartile, again, first quartile by definition is going to be the median of the data set that will come before the median of all the data. And so you're looking at, for the first quartile, you are looking at the first 5 data pieces. So you're looking at the median of 17, 17, 17, 18, 19. And again, the first quartile is going to be the median of the first 5 data pieces. So it is going to be the third 17 that lies. And in the case of the third quartile, that is going to be the median of the last 5 data pieces from the set. And so the third quartile will be the third number that comes after the median, and so that would be the number 28. And there is a mode in the set, and 17 appears 3 times more than all the others, so that is going to be the mode. In terms of the mid-range, okay, that is going to be taking the mean of the lowest and highest values, and so that comes out to 38. Now for the range, that is going to be the difference between the highest and the lowest values. So we have 59 minus 17, so that would be at 42. And in terms of the variance and the standard deviation, okay, for the items that we need, okay, we need for the values x, everything listed from 17 all the way up to 59, everything else between, and also listing the squares of the value. 17 squared is 289, 59 squared is 3481, and adding in the other squares, okay, we're going to come to a grand total where the sum of the squares is at 9558, and the sum of all the billions we have among the 10 wealthiest individuals we have at 272. And now for the variance, okay, this is going to be the algorithm here where we're looking at the number of billionaires in the data times the sum of the squares of the data values, okay, and then we have minus the square of the sum of the wealth in the billions, okay, and so then we have divided by n times n minus 1, so substituting accordingly, we have n is at 10, the sum of x squared we have at 9558, and then we have for the square of the sum of x, you're looking at the square of 272, and this difference is going to be all over 10 times 9, and as we take the difference, okay, 10 times 9558 minus the square of 272, that's going to be 21,596, divided by 90, and so we have for that quotient, the variance amount is going to be at 240, and leading up to the standard deviation is going to be the square roots of that value, and so we have for the billionaire set, okay, we have for the standard deviation, this comes out to right at 15.49, or right at 15 and a half. Now, in the case of what we have in number 4 with the SAT scores, okay, we'll be looking at the mean, the modal class, the variance, and the standard deviation. And so far as what we have for the classes, okay, we have 478 to 504, all the way up to 586 to 612. And then we have for the frequency numbers, you have 46222. Okay, so you have 16 for the sum of the frequencies. And now we do not have the itemized data values, but we can use once again the frequency table to determine the mean, and that again is going to be utilizing the class midpoints, and again that is going to be the corresponding mean of the lower and the upper class limits. Okay, so for the first class, okay, the midpoint is at 491, second class 518, mean of 532 and 558 in the third class gives us a midpoint of 545. And then rounding out the rest, you have 572 and 599. And in calculating the mean, we need to take the product of the frequency and the midpoint. So we have 4 times 491, 6 times 518, 2 times 45, 2 times 572, and 2 times 599. So we have these respective products, and adding all of these together, we have 8,504. And for the mean, you take that particular sum divided by the number of data pieces, and so we have 8504 divided by 16, so this will end up at about 531 and a half. Now for the modal class, that's going to be the class with the highest frequency, and so that will be 505 to 531. And so far as the variance goes, okay, adding in this remaining column, you're looking at the frequency times the square of the class midpoint. Okay, and so we have for these products, we have these rather large numbers, and adding them all together, we have 4,540,288. And looking at the variance, we have S squared is equal to the number of data items, again, which is going to be at 16. Then we have times the total from the last column, that is going to be the total of the products of the frequencies, and the squares of the midpoints, and then we have minus the square of the sum of the products of the frequencies and midpoints, and then we have once again all over n times n minus 1, and substituting in the values accordingly. Okay, we have 16 times 4,540,288 minus the square of 8504 all over 16 times 15, so we have the difference at 32,000, or make that 326,592 divided by 240, and so we have 1360.8. Again, that is the value of the variance, and taking the square root of this is going to give us a standard deviation. And in this case, we have for the square root of 1360.8, we have about 36.9. Okay, now in terms of what we have for number 6, same kind of setup. And in this one we have 7 classes and varying frequencies. And so for what we have in the data set, from 10 to 12 to 28 to 30, very narrow class width. In fact, class width is only 3 for each of these numerical ranges. And we have the corresponding frequencies to add up to 50. And for the mean, once again, we take the midpoint. So we have 11, 14, 17, 20, 23, 26, 29. And multiplying each midpoint by the corresponding frequency, we have the corresponding products in this case, and the grand total is going to be at 925. And taking this and dividing by the number of data pieces, this is going to arrive to the mean, which we have at 18.5. Again, the modal class will be the class with the highest frequency value is at 15, and thus the modal class is going to be at 19 to 21. And once again for the variance, okay, again we have we need once again the product of the frequency, and not just the midpoint but also the square of the midpoint. So with this added column, okay, so you have 6 times the square of 11, which would be 726, all the way down to 1 times the square of 29, which would be 841, and including all the other values, we have the total from the last column at 17,981. And plugging in the numbers once again into the variance algorithm, okay, we have 50 times 17,981 minus the square of 925 all over 50 times 49, and the difference we have at 43,425, and divided by 2450. Okay, we're going to have in this particular case the variance is going to be at 17.72, and relatively speaking, the standard deviation of this problem is going to be quite small. And so for the square root of 1772, okay, the standard deviation is going to be around 4.2 or 4.21.